is to solve a system of equations using matrices. So yesterday we laid the groundwork. Okay, I told you what a matrix was. We learned about what an augmented matrix was. We learned about the row operations, and then I showed you the row echelon form and the reduced row echelon form. Our problem of the day. What form is that augmented matrix in? Okay, it's in row echelon form. Do you agree that if our augmented matrix is in row echelon form, it's nice to solve? Okay, so what we can do here is if I give you a three variable system of equations, we can write it as an augmented matrix, and we can perform our elementary row operations until we reach row echelon form, and then we can easily solve for x, y, and z with very minimal effort, right? So I have our system of equations already written in to our augmented matrix, okay? So go ahead and write this augmented matrix down. So if we are getting this into row echelon form, then we want these numbers right here to be ones and everything below it to be zeros, okay? So this is kind of like a puzzle, all right? Some of us may do it different than others, but if we're solving a system of equations, as long as our math has been correct, we should get to the same answer. Okay? So we need one row that starts with a 1, one row that starts with a 0, 1, and a third row that starts with 0, 0, 1. Let's remember that we can switch rows, we can multiply a row by a number, and we can combine rows together by either just adding, subtracting, or multiplying by a number and then combining. Okay? So here's what I see first. Do we have a row that begins with a 1? We want that to be our first row. So I'm going to switch row 1 and row 3. Okay. Now we want to work on some zeros. Okay? So in our second and third row, doesn't matter which one we pick, we need one of them to be 0, 1, and we need another one to be 0, 0, 1. Okay? So does anyone have an idea on making the first entry in either one of those rows a 0? Jackson, what do you see?
We could multiply the second row by 2 and add the third row to it.
Okay, so we can take our second row right here and multiply it by 2 and add it to row 3, and that can become our new row 3. Was that your intention?
No, I said you can add row 3 to it, and then you would...
Oh, that would become our new
row 2.
Row 2. Okay. Dave, did you also have an idea?
I was just going to say you can add one row 1, row 2. Makes it minus
Okay, so we have 2 different ways we can do it. We could multiply row 2 by 2 and add row 3 to it, or we can add row 1 and 2 together. Okay? Now, we're all going to do the same thing, but if you were working on this like on your own, it would not matter which way you went, but your answer may look different than Jackson's if Gabe and Jackson's may look a little bit different when we get to the end. Okay? So let's go. Who wants to add row 1 and 2 together? Jackson. What? Okay, so let's add row 1 and row 2 together, and that's going to become our new row 2. So 0, that's convenient. 1, 3, 5. Check my math. I know you trust me, but sometimes I do add incorrectly. Well, this is nice, isn't it? Row 2 is taken care of because it's 0, 1. Now we need to focus on row 3. We need row 3 to be 0, 0, 1. Okay? It is going to be best if you start with the first entry in the row, make that 0, and then move to the second entry and try to make that 0. Okay? So if I want this to be a 0, is row 2 going to be helpful? Row 2 is not going to be helpful. Row 1 can be helpful. What would we need to multiply row 1 by to combine with row 3? -2, right? So we need to take -2 times row 1 and add it to row 3, and that's going to become our new row 3. Okay, so we have -2 times 1 plus 2. -2 times -2 plus -5. -2 times 3 plus 5. Got another -1? And then -2 times 9 plus 17. Do you agree with 0, -1, -1, -1? Not very exciting, but that's what happened. Questions on how those numbers are, how we're getting those numbers? We're following along okay? So now for row echelon form, we need that third row to be 0, 0, 1. So let's first focus on making that second entry in the third row a 0. Should we use row 1 to help us? Please do not. We've already made this a 0. Using row 1 would cause that to not be 0 anymore. Okay? So our only option really is row 2. What can we do with row 2 and row 3? Add them together, and that second entry becomes a 0. So we're going to take row 2 and add it to row 3, and that becomes our new row 3. So we have 0, 0, 2, 4. And then how do we make, is this in row echelon form?
No.
It's so close, Darby, what do we need to do? Okay, this 2 needs to be a 1 instead. So all we have to do is take row 3 and multiply it by what? 1/2. Caroline.
So do you have to take it all, if the goal of the problem says to solve the system, do we have to, first of all, do we even have to use matrices? And then second of all, did you just like stop there because you can just say 2z equals 4 and then just divide by 2?
Okay, so first of all, in this chapter, yes, I want you to use matrices to solve systems. okay? What's nice about systems of equations is we have a lot of different ways we can solve it. In chapter 7, we focus on the algebraic part. In chapter 8, we're going to focus on the matrices method, okay? So when you get to the ACT and you get a system of equations, you can choose what you want, okay? There are going to be questions in your book that just solely ask you to put it in row echelon form, which is what we've done here. When I ask you to solve a system using an augmented matrix, I do expect row echelon form. Now, you're saying we can obviously solve it. Okay, if you write 2z equals 4, you're going to have to divide by that 2 anyway. So I want you to go ahead and do that in a matrix. Okay, so let me say that again. It is my expectation that if I ask you to solve a 3-variable system with a matrix, you get it all the way to row echelon form before you figure out what x, y, and z are. Okay? Yes?
And also, so wouldn't every augmented matrix have an infinite number of rows and zeros at the bottom?
No. So this one only had 3 rows. And that's it. Now, if this augmented matrix would have had 4 rows, so if it would have been a 4 by 4 matrix, then we would have had a row of zeros at the bottom, because 4 equations is like one too many. Let me rephrase this. If we have 3 variables, technically we only need 3 equations to solve. But like on our chapter 7 test, we wrote a 3-variable system with 4 equations. If we would have put that into an augmented matrix, we would have had a row of zeros at the bottom. Because there's like one more equation than variables.
Okay. So then, so like if you had like, so say if you also had on here, just make something up, if you also had,
If we had a 4th row,
yeah, like, but like in the very beginning, oh, I guess we started with, but like, I don't know, you would have another equation, so you would just like throw it out,
we would not throw it out.
you just have a, and you have to eventually solve it to all of it.
Right, because we want the seatbelt of 1s, right? So if we had a 4th row, okay, we can't have 0, 0, 0, 1. That wouldn't make
Yeah.
sense, so it would just all have to be zeros.
Okay, so then my question is though, but in every system equation, wouldn't you also just have like 0x plus 0y plus 0z equals 0 because it would have to be, and then would you have
Yes.
like an infinite number of zeros at the bottom of your matrix?
I mean, we could, but we're not going to write them.
But like, would you ever need to write them?
No. You would not need to write this. So if you have 3 equations, you're going to have 3 rows. And then just stuff.
You solve a 3-variable system with 2 equations if you added a 0 and then you added another row to it.
Okay, so that's a good question. If you have 3 variables, but you only had 2 equations, we call that inconsistent. There's not enough information for us to solve. We would not be able to put that into row echelon form.
But you could manufacture a 3rd equation
No.
by using
Well, but it wouldn't help you solve it. I mean, you could put 0, 0, 0, 0, 0, but it's not going to help you get it into row echelon form. Okay, so you may come across a problem in your book where there's, like if you have 3 variables but only 2 equations, that's not enough to be able to solve for all 3 variables. You would call that an inconsistent system.
So what are supposed to, so like when we answer it, we just write inconsistency.
Okay, very good. Okay, we can talk later still if you need to. Okay. Okay. So this started out as an augmented matrix. All I asked you to do was to get to row echelon form, and that's what we did. Okay. Now let's say I gave you a system of equations, and I said, hey, use an augmented matrix to solve this. Okay. You could write it as this, get it into row echelon form, and then you have kind of what we did on the board for our problem of the day. right? Z equals 2. There's one answer. Y plus 3z equals 5. Figure out what y is. Makes sense. Okay. This is going to take some patience on your part, and my goal is to give you some work time at the end of class. Okay? It is important that you write down what you are doing. It's going to be very easy to mismultiply or misadd or write down a number incorrectly. So if you notate every step, it's going to be a lot easier to go back and find a mistake. Okay? But with these 3x3 systems in an augmented matrix, you're going to need some patience. Okay. Let's go ahead before lunch. We're going to solve this 2x2 system.
2x3.
So when I say 2x2 system, I mean 2 equations, 2 variables. I'm really sorry that was confusing. Let's solve this 2 variable system. Better?
Yeah.
Okay.
Using augmented matrix.
Yes. In the matrices chapter, you will not be using substitution or elimination to solve a system. Okay?
Wait, what's like the point of this? Like, when would you use the matrix?
So this is just, that is not true. This is just another way to solve a system. Like, what does this represent? 2 lines intersecting, right? And we worked with a lot of word problems last chapter that involved 2 lines intersecting, right? Okay, so instead of substitution or elimination, we can use a matrix. Sometimes it's nice to have options. Do you agree? Like at lunch, you don't just have one thing for lunch. You have like a variety of things. Maybe you don't feel like doing substitution or elimination. You can do this. Caroline.
Okay, well, I did one step of this, but then I have a question. So can you multiply the first row by 1 month?
That's always a possibility, yes. You can multiply by any number as long as it's not 0.
Okay, so can you stop because then on the next.
Okay, so, here's our augmented matrix. It is my expectation that when you have a 2 variable system, you get to reduce row echelon form. With a 2 variable system, it is only one extra step from row echelon form to reduce row echelon form. So that is going to be my expectation. Okay? Now, Caroline, you want to multiply this by 1/2 so we have a leading one? Sure. So we can multiply row 1 by 1/2. So we have 1, 3, 8.
So now we need to have everything 0 in our set, right?
Mm-hmm.
Like, so you said that you can't multiply the bottom of 0.
You cannot multiply by 0 ever.
Okay. So then I'm thinking.
Because then it all go to 0.
Yeah.
And then there's no point. Yeah.
Can we multiply by negative 1/2 instead? Because I feel like that might save us a step.
We're going to have the same number of steps regardless of if it's positive or negative. Okay, we want this positive 1, so it's actually saving us a step, making it positive. But you're thinking, okay, we want this to be 0, right? So we can take negative 2 times row 1 and add it to row 2 to make this a 0. Okay, so if we take negative 2 times row 1, we have negative 2 plus 2 is 0. Negative 6 plus 3 is negative 3. And what? Negative 16 plus 7? Negative 9? Yes.
What I say we do before we divide the bottom by 3 is we could, like, add into the top and down.
Okay. So Jackson's thinking like multiple steps here. If we want reduced row echelon form, remember reduced row echelon form would be this, whatever those numbers are, okay? So we know that this needs to be a 0 and this needs to become a 1, okay? We all know that multiplying that third row by negative 1/3 is going to create this to be a 1. But if we want this to be a 0, Jackson's saying, can we just add the 2 rows together right now? Yes, we can. So we can take row 1 and add it to row 2. 0 plus 1 is 1. Negative 3 plus 3 is 0. And then negative 9 plus 8 is negative 1. And then to get that last row to be 0, 1, we can take row 2 and multiply it by negative 1/3. So now what does this mean? This means x is, y is 3. So the solution to this system right here, what do we say, negative 1/3? Okay. Now, some of you may argue that this is a lengthier process. Some of you may argue that this makes more sense in your head. You're going to have your preferences, okay? Right now, you're going to have to do this, but there's going to be a time where you get to choose how you want to solve the system, okay? Here I am exposing you to all of the different methods, okay? There will be another way we can use matrices to solve a system, and we'll learn about that on Thursday. So in the matrices chapter, I'm going to show you 2 different ways to solve a system. Okay. Now, let's think about this. If we have like 4 variables, I know you wrote one with 4 variables in your homework last night. Okay. By hand, like using algebra, that might be kind of awful, but with a matrix, it's a lot easier to organize. Okay. All right. So it's lunchtime. When you get back from lunch, you need your graphing calculator out. Okay. So anytime you want to use your calculator, you have a menu dedicated for matrices. Okay? So everyone turn their calculator on. And so this first step, it says select matrix menu. The matrix menu is right here. Do you see the X to the negative 1 button? If you press second and then that button, you are at the matrix menu. Okay. I do not have any matrices stored in here. Okay. There's 3 menus. This just is the list of matrices. There's the math menu and the edit menu. If you arrow over to edit, you can select a matrix that you want to edit. So I'm going to select A. Okay. So it says input the order row by column. So what I'll have you go ahead and do, is write down that system of equations for me in your notes so you know what we're solving. What is the order of the matrix that we need to type in? 3 by 4. So right here, this is where you input the order. So if you press 3, enter, and then 4, enter, it'll give you a 3x4 matrix. Okay? Now, if you have the 84, it's a much cooler screen than this right here. But some of you do have 83, so it looks like this. But regardless, we're going to be able to enter in our values. So our first row is going to enter your entries by row. Okay, so your first row needs to be 3, -2, 1, 15. Okay, you enter in your values, I'll enter in mine. Does anyone need more time? Okay. So once you have your matrix entered, to get back to the main screen, press second and quit is right here. Now, if we go back to the matrix menu, remember how to get there? Whoops. Okay. Under the math menu, there are a bunch of different things that we can find regarding a matrix. So go ahead and hit the up arrow because we want to go to the bottom. First, I'm going to show you REF, row echelon 4, REF. So if you press that, it like has an open parentheses. You need to put the matrix inside of it. We entered our information in matrix A, correct? So if you go to your matrix menu, this first menu with names, we want the first one, matrix A. You can call it up to actually perform the reduced row, or the row echelon 4. To scroll over, you would need to like arrow up and then scroll to the right. Maybe hit enter. And then that's where you should be able to do that. We'll play with it. Okay, now if we have our calculators, we really want to do algebra. No. If we have calculators, there is no point to row echelon form. Let's go ahead and go to math and click REF, reduced row echelon form. And then it's much easier to determine the answer to our 3x3 system. This system has a solution of 5, -1, -2. What, Gabe?
I could look stuff up. I didn't know what.
Well, here's the deal. On the quiz on Monday, there will be a calculator portion and there will be a non-calculator portion. You need to be able to do this both ways. Okay? Now, you can use this to check your reduced row echelon form. Okay? Or you can use it to check your answer. Okay? The biggest part about matrices on your calculator is the time it's going to take you to input everything. Okay? But understand how to use matrices and you have your calculator, you can use matrices to solve systems with your calculator on the ACT. That's pretty sweet, right? Okay, so you have some homework. The book will specifically tell you when they want you to use your calculator. If it doesn't say use your calculator, then don't use your calculator. I would like to give you some work time. We have like 15 minutes left in class. A little bit more. I want you to work on some problems. That way, if you come across some issues, I am here to assist you. Okay? So everyone is getting their book out or sharing a book, and everyone's working on their homework.